All right, let's get going. So thank you all for coming. Last session of the day. We're going to have some fun, and hopefully I'm going to educate you as well. Everybody enjoying PAS so far? Excellent. That's what we like to hear. That's why we come and do this. All right, so this is me. My name's Parental. I used to work on the SQL Server team, blah, 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 as it says down at the bottom, okay? Lots of really boring stuff. Interesting stuff. Blogs. So all of us at SQL Skills, we all have blogs. There's no marketing, advertising, any of that kind of junk, just lots and lots of free information. I encourage you to go and look at our blogs, okay? Now, it's SQL Kilt Day. I'm obviously not wearing a kilt, okay? Here's a picture of me wearing a kilt. The one and only time in my entire life that I have worn a kilt. It was very liberating, let's say. Okay? And I did, and that's my dad standing next to me for my sister's wedding. We did go au naturel, like true Scotsmen, okay? Now in Scotland, kilts are not where it stops. This is a picture of me wearing a dress. Okay? The one and only time, I might say. Thank you very much. Yeah, the one and only time, okay? This was actually a fancy dress party that I dressed up as, okay? So maybe there should be a cross-dressing day next year, maybe. You never know. You know, it could take off. It could take off. Yeah, no. Okay, so this is not me in any kind of costume. This is Jonathan. Okay. No, this is a sheep. I really like sheep. As you know, this is my Twitter avatar. There was a question on it in the quiz bowl. But I like sheep. I want to make it very clear in a family-friendly way. Okay? All right, so that's me. This is my life. Okay? This is also Jonathan's life as well. Very famous XKCD cartoon. You ask Kimberly when she's presenting tomorrow, she'll tell you this is absolutely true with me. You ask his wife Sarah, it's absolutely true with him too. Okay? Because there is so much misinformation out there. Okay? It's not malicious. You know, things change. The behavior of SQL Server has changed over the years hugely. So what was the behavior a few years ago or a few releases ago might not be the behavior now. There's also people that blog stuff and they kind of misinterpret what the behavior is, so people get things wrong. You guys go out there and read that, and it becomes myth and legend, and so it becomes a real pain because you go and implement stuff that's wrong, which could lead to downtime, data loss, poor performance, all kinds of stuff. Okay? So last year, my spotlight session was DBA Mythbusters, so I thought, because you guys enjoyed it so much, I would come up with another 30 or so, and we'll debunk some more of them together. Okay? So this is how this works. I put a myth on the screen. And you guys shout out true or false. Okay? Rockin'. Okay, this one's obvious, right? Let's get to the fun ones, the real ones. Number one, data compression is only for data warehouses. Absolutely. So when we designed data compression, it was actually my dev team that designed data compression back in the 2005, 2006, 2007 days. We thought it's a data warehousing feature, because what we designed it for was for reading very, very large data sets into memory and not processing them again. The reason for that is there is no cached, decompressed copy of the information in memory. So whenever the query processor says to the access methods, please get me this column off this compressed page, the compressed page is read into memory, the access methods does all the decompression, and gives it back to the query processor. If the query processor then says, get me the exact same column again, it gets decompressed again, and again, and again, and again. So you're burning a whole bunch of CPU time. And this is why we thought that this wouldn't be suitable for OLTP systems. But as many of you probably know, most systems nowadays are not CPU bound. They're IO bound. So people have got lots and lots of CPU headroom. So we're seeing a lot more people, and some of you out there are probably doing it yourselves, are using data compression on either mixed workload or pure OLTP systems for the massive amount of space saving you can get. I know of plenty of customers of Microsoft, customers of ours, where they're saving multiple terabytes worth of data by having compression turned on in pure OLTP servers, because they can afford the CPU headroom. And they'd like to get the multiple hundreds of thousands of dollars TCO savings a year from not having to have that enterprise class storage. Okay, so data compression very much not a data warehousing feature, even though when 2008 was released, it was touted as a data warehousing feature. Number 2. True or false? Maybe. Okay? It depends. Read the back of the shirt. Okay? It depends. 3 times ever I have seen it work. Okay? And that was not because of anything to do with SQL Server. It was because of the I/O subsystem. So 3 times in my life, I have seen an I/O subsystem where I/Os have just got stuck. And that can happen, bugs in the I/O subsystem. If you think of the I/O subsystem, most people think it's a bunch of hardware. It's not. There's tens of millions of lines of code sitting there running all the various controllers. And wherever you've got code, you've got bugs, just like in SQL Server. Right? So 3 times I've seen restarting the I/O subsystem and SQL Server fix a corruption. Now, because of those 3 times, would I ever recommend bouncing SQL Server to try and fix corruption? No. Okay, so don't do it. Oh, down at the bottom. Detaching a suspect database, one of my favorite stories and things to play with. If you're on 2008, you can't do it now. You have to work really hard to do it. It will actually not let you run SP detach DB on a suspect database, which is fabulous. I'm so glad they fixed that. Number 3, truncate table is non-logged. True or false? Yes, busted. So it's very interesting, though, because it seems like it's non-logged. It seems like it's really fast. Okay? And there's a good reason for that. So truncate table is, you could almost describe it as minimally logged, but it's not minimally logged. It's actually fully logged, but it's logged very, very efficiently. The only thing that's logged are the deallocations of pages and extents. Now, it's not a true minimally logged operation because true minimally logged operations, their behavior changes between the full and bulk logged or simple recovery models. Okay. This one's not. This one's just a regular fully logged operation. Now, back in 2000 SP3, we changed the way that deallocations were done. Thank you.
Your coffee, Mr. Randall?
Thank you.
A fruit plate?
Oh, excellent. Thank you. Thank you.
Will there be anything else?
That's all, thank you.
Thank you.
So in 2000 SP3, we made a change to the storage engine because what we were finding was people had such big tables in 2000 that they weren't actually able to drop or truncate their tables. And the reason was because whenever a table was dropped or truncated, in about another hour, Buck, another hour or so, another one? Thank you. Yes, please. The side entrance, please. I don't want to sign any more autographs and stuff. Thank you. So these tables were getting so big that they were running out of lock space. What do I mean by that? So whenever a table was truncated or dropped, what happened was an extent allocation lock would be taken, and then the storage engine would do kind of instantaneous lock probing on all 8 page locks in that extent. And if all 8 page locks were available, then the extent could be deallocated. But the extent lock was held until the end of the implicit or explicit transaction wrapped around the truncate. So the larger the table is, the more extents there are, and the more locks were taken, the more lock memory there is, and we were having people actually running out of memory. So in 2000 SP3, we put in this feature called deferred drop, which means that depending on the size of the table, when a drop or a truncate happens, the allocations get unhooked and put onto what's called the deferred drop queue. And there's a background task that goes and deallocates it in little chunks. Okay? But truncate is completely logged. Let me quickly prove that to you. So I have here a database. This is the only way I'm going to use a sheet. Okay. I've got a table. I've got 1,000 rows. My font's big enough. I don't need to use Zoom it. I'll use Zoom it later. All right, so I stick 1,000 rows into my table, and I run select count star, and I've got 1,000 rows. If I do an explicit transaction and a truncate table, and then I do a select count star, 0. Table's been truncated. However, I can do rollback tran, and then a select count star, and my table's there again. Okay? That couldn't happen if the truncate table was non-logged. Okay? Because that rollback took all the log records that the truncate generated and generated the anti-operations and put everything back again. Okay? So there's proof that it's logged. Okay, where's my clicker? Srin? Absolutely. Okay, so paraphrasing Kevin's question. You do the truncate, and in the meantime, somebody comes along and reuses that space. How do you do the rollback? When the deallocation is done, the lock is held until the end of the transaction, whether it's explicit or implicit. So if there's an extent allocation lock held, nobody on another thread can allocate from that extent, and they can't allocate that extent itself. So in essence, it's still kind of pseudo-allocated. Okay, so the space can't be used by something else. Okay. Number 4, Datafile shrink does not affect performance. Can't even say that with a straight face. True or false? Anybody gets this wrong, you're out. Okay. Totally busted, yeah. So, not just because of the fragmentation it causes. Shrink is an incredibly expensive operation. Okay. It was written before I took over the code. I want to make that absolutely clear. I was never allowed to go and rewrite it. Get this, it was never deemed important enough a problem to get it rewritten. But while it's running, it's picking up pages, and it doesn't just pick up the page image and move it somewhere else. It takes all the rows and one by one by one by one, it moves them to the new page. Okay? It doesn't do any kind of compaction or anything like that. So everything that it's doing is completely fully logged, no matter what recovery model you're in. So it's causing fragmentation, it's taking locks, it's burning CPU, it's generating transaction log, it's generating IOs. Okay? Don't do it. Well, maybe. Okay? People often misquote me and say that I always say, don't do a shrink. Okay? I don't say that. Don't do an auto shrink. Shrink, maybe, if you absolutely have to. But be cognizant of the fact that it causes fragmentation. Number 5. SQL Server does in-place updates of key columns in indexes. True or false? You're not so sure about this one. It's false. Unfortunately, everywhere that has this documented has it unfortunately wrong. Okay? SQL Server has to do a full record delete and insert to get this correct under the covers. Okay? Now, when you delete a record in an index, it doesn't get deleted, it gets ghosted, and then the ghost cleanup task, bless it, goes and cleans it up in its slow way. Because the record hasn't gone yet, it's still taking up space on the page. So when the new record gets created, if there isn't enough space on the page, what's going to happen? Page split. Okay? So updating a fixed width key, which you wouldn't think would need any extra space, will actually require length of record extra space on that page. And I did a blog post 3 or 4 months ago that actually showed you this and showed you the case where a page split occurs for updating a 4-byte integer value. Okay, nasty stuff. Number 6, using snapshot isolation has no effect on performance. True or false? You guys are good. Yeah. Well, it depends, because it does cause some issues, but the issues it causes could be vastly outweighed by the gains it gets you. Okay. Snapshot isolation is a fabulous way of alleviating blocking and deadlocking problems. However, it has some interesting side effects. Whenever a row is updated, okay, and snapshot isolation is enabled in either of its 2 forms, a 14-byte tag is added on the end of the row. The 14-byte tag has a pointer into the version store in Temp DB and the timestamp of when that version of the record, the one that's left on the page, was created. Okay. What happens if the page is completely full and there's no space for that 14-byte tag? Page split, absolutely. Okay. So turning on snapshot isolation can actually lead to fragmentation issues, okay, both logical fragmentation and page density issues. So you might turn on snapshot isolation to solve one performance problem, and suddenly you've got another one under the covers. Okay. You can easily work around that, though, by using a fill factor on your indexes. So it's not a reason. I'm not saying don't turn on snapshot isolation. Okay, I'm just trying to make people aware of this problem that can occur. Now, of course, the other thing that happens with snapshot isolation is you start hammering Temp DB even more. because you're pushing stuff into Temp DB and you're pulling stuff out of Temp DB, okay, potentially. So yeah, it can have performance issues. Checkpoints only write committed changes to disk. True or false? That's good coffee. Yes, false. Checkpoint will write all dirty pages to disk. Now, a dirty page is one that since the last checkpoint or the page was read in from disk has been changed for whatever reason. It doesn't matter if a transaction started, changed the page, and then rolled back. That page is still dirty. Right? You might think, well, why does it need to get written to disk? And I've seen people get confused because of differential backups, for instance, where they do a ginormous transaction that does lots and lots of changes, and then they roll it back. And their differential backup is enormous. And if that's the only thing they've done in the database, they're saying, well, why is my differential backup anything bigger than 0? Because I didn't make any changes. Well, you did. Because everything you do on the forward part of your transaction touches a page. Okay? Generates a log record, increases the log sequence number on the page. If you roll it back, it has to go and generate more log records to do the ANSI operations, which goes and touches the pages again, changes the log sequence number. So for transactions that have rolled back, either for checkpoints or differential backups, they will be included because they have changed. The net effect may be nothing, but as far as SQL Server is concerned, the database changed. And so that change has to be pushed out to disk for a checkpoint, or it has to be backed up from a differential backup. Okay. Now there's a DMV, a very cool DMV, DMOS buffer descriptors, and you can use that, and I've blogged recently a couple of scripts where you can use that and look inside the buffer pool. And one of the things it can show you is what's in the buffer pool. And you can go and join various other DMVs, because the DMVs are useless unless you join like 6 of them together, which is a shame. You can use that DMV joined with a bunch of other ones to see for any particular database how much of it is in the buffer pool. And within that database, which tables, which indexes are taking up space in the buffer pool. Furthermore, what's even more interesting is for every one of the buffer structures that the buffer pool keeps to keep track of, which pages are in memory, it's also tracking in real time the amount of free space that there is in that page in memory. So you can use this DMV to look inside your buffer pool and see how much of your precious buffer pool memory is actually storing nothing. Okay? And you might be surprised. There was a survey that I did on my blog, again, a few months ago, I can't remember exactly when, where I sent out this script and said, hey, go and run this. And I got data back from 600-700 random people around the world. And we found a bunch of servers with tens and tens of gigabytes of memory, and more than 50% of it was free space, because they had such bad fragmentation problems in their pages. Okay. So very interesting. See, I go off on tangents. Next up, what's next? Oh, this is a good one. Adding the 9th or 17th, 23rd column to a table, okay, is always going to result in a size of data operation. Now, by a size of data operation, I mean every single row has to be touched right there. True or false? Ooh, interesting. Who said it depends? Well done. Okay. It depends on the default value for the column you're adding. Up until SQL Server 2012, it depends. Okay. If you're adding a null value, then there's no reason for the storage engine to go and touch every page. The storage engine metadata, because metadata is split into 2 parts. When you do a create table, you create some relational metadata. That doesn't tell anybody how the stuff is actually stored on disk. There's another set of metadata called the storage engine metadata, and that's what the storage engine uses to find everything, crack open the records, and so on and so on and so on. The storage engine metadata will remember that some of the records in this table might not have this extra column. Okay. From SQL Server 2012 onwards, this will also work for non-null defaults as well, which means that what is now a size of data operation can now be an instantaneous operation in SQL Server 2012. That's really cool. I like that. Okay, Kevin's question is, how does that work? So, it's an easy paraphrase, yeah? Yeah, quickie. We got plenty of time. We're here till 8, right? Yeah? Okay. Yeah. 9, perfect. You know me and Kimberly, we can talk for hours. How does it work? So, when the storage engine is cracking open a record, the code loads the metadata, and I'm thinking about what the code's doing. The code loads the metadata, and it instantiates 2 record crackers, if you will. One called a short record cracker, one called a long record cracker. And they both look at the metadata. And the storage engine metadata will say whether there is the possibility of extra columns. Now, this is not just for these extra columns that we might have just added. Think about dropped columns. So you do an alter table drop column, okay, and it completes. But the column's still there for some of those rows. It's not going to get removed until the next time you do an index rebuild. Okay? So how does it cope with that? In exactly the same way. It keeps track of every single possible column that there could be in any record in the table. So think about the drop column case. You insert 1,000 rows into your table. You drop a column. You insert another 1,000 rows into the table. You've now got 2 physical schemas, if you will, okay, for those rows, both representing the same relational data set. But the storage engine has to cope with those. And it does it just by keeping a list of these are the columns that comprise the record. They may or may not all be there. Okay. Number 9. Temp DB data file should be one-to-one with processor cores. This is one of my major bugbears. Thank you. Well, it depends. Okay. So, for the longest time, well, back in the 2000 days, the one-to-one guidance was cool. That was fine, because we were all running, small machines, 2, 4, 8 processors, something like that. Nowadays, we're all running, well, we're not all, but a bunch of us are running super machines, 32, 48, 64, 128, 256 logical processors. Okay? So the one-to-one guidance is wrong. Unfortunately, the Microsoft official guidance is still one-to-one. Okay? They now know it's wrong, and they are in the process of changing it, which is good. The various white papers that still say this are going to be updated. Okay? Now, from 2005 onwards, who's in Bob's session yesterday? A whole bunch of you. So very, very quickly, I'll speak very quickly. Okay, in 2005, we put in temp table caching, and that alleviates some of the contention problems. You can still have contention problems, though, which means you still have to have extra data files. Right? But not one-to-one straight away. So what everybody else apart from Microsoft has been saying since 2005 came out was, instead of going one-to-one, because going one-to-one on a system with lots of CPUs can actually slow things down. Right? Because you run into some of the algorithms that are happening under the covers. Proportional fill, for instance, recalculating all those weightings and stuff. The more files you've got, the more frequently that can happen, and the slower it can be, yada, yada, yada. So what we've all been saying is, if you have temp DB contention, the number of data files you should have, take your number of logical cores and start with maybe 1/4 to 1/2 that number, and then work up if you're still seeing contention issues. Okay? Now, Bob yesterday came up with an interesting spin on that, which I like, which is if you have less than 8 cores, just make it one-to-one. If you have more than 8 cores, start with 8, and then if you have contention issues, add in more data files in chunks of 4, okay, until you're not seeing contention anymore. Now, this is all a massive generalization, because I know of at least a couple of cases from PSS on 64-core machines where the contention was so bad that they could only alleviate it by creating 128 data files, which is 2x. Okay? So there's no absolute value, and Bob said this yesterday, there's no absolute value. It's going to completely vary for every single one of you in the room. Okay? The thing you have to do is have a look and see what contention you've got, maybe up the number of files and see if your contention goes away. Right? If you can't change your application, you can't change your workload, add some more data files. Right? At some point, you're going to see it start to slow things down, though. Okay? So don't immediately go number one-to-one. Oh, log files. How many log files should you have, basically? 1. Excellent. Okay. Now, there is a case where having more than 1 log file is potentially helpful, but it's not for regular performance. Right? It's if you run out of space in your transaction log. and you don't want to have to essentially throw that transaction log away by bouncing the server or bouncing the database into the simple recovery model. Temporarily add another log file to allow things to continue. Okay? And then once you've finished with that log file, get rid of it. Keep your manageability simple. I don't have it on this slide, but we're doing pretty well. There is actually a case where multiple log files can help you with performance. Okay? If you have a gigantic transaction log, and you need it to be gigantic, and you're doing a complete from scratch restore, and we're talking like terabytes of transaction log. Right? If you have multiple log files and you have multiple, you have them each on a separate physical device, you'll get separate backup threads, and your log restore will go faster. Okay? But that's a very niche case. I say niche because I'm from Britain. You guys say niche because you're all American. That's a very, very niche case. Okay? That's not go out and create multiple log files. Okay? The vast, I don't know of one customer that's ever done that. Okay? But that vast majority of you, one log file is going to be absolutely fine. Now, if you create multiple log files, you will see IOs happening. What's through that door over there? Oh, cool. Okay. Oh. Was it interesting? Slightly interesting. Okay. Maybe I'll check it out afterwards. Multiple log files. If you create multiple log files and you do IOs and you generate transaction log, occasionally you will see IOs going to those other log files. Okay? It's not writing log records. If you have multiple log files, it's going to use the first log file, then the second log file, then the third one, and then kind of wrap around. But occasionally you'll see IOs go into these two as well. It's updating the file header pages. Every data and log file has an 8K file header page, which contains information about the files themselves. Log file header pages also partially mirror the boot page of the database, page 9 and file number 1, which allows you to do tail of the log backups if your data files have been damaged after a crash. Okay, I'm going to show you that later on. Okay. The log can use instant file initialization. True or false? Ah, you guys are the smart class. Yes, busted. Now, why? The reason is to allow crash recovery to work properly. Think of the case where you've got a new transaction log and you haven't yet written all the way to the end of the log. Okay, so the log hasn't wrapped around and started reusing itself yet. So maybe you're 3/4 of the way through the log. System crashes. So the way crash recovery works is it opens up the boot page of the database. In the boot page of the database is the log sequence number of the last checkpoint that occurred. The log sequence number of that log record contains there'll be potentially three log records for a checkpoint. Begin and an end always, and maybe what's called a payload log record. The payload log record has the starting log sequence numbers of the oldest active transactions at the time the checkpoint occurred. Crash recovery has to start at the lesser of, or the older of, the last checkpoint, or the oldest active transaction at the time that checkpoint occurred. Then it starts reading through the log. Okay, there's 3 passes through the log, but essentially, it doesn't know where to stop. Okay? So we have to have some mechanism to allow it to know where to stop. The first part of the mechanism is it carries on reading until it reads a log block that's full of zeros. Guaranteed that it's reached the end of the log, because log blocks are always allowed on 512-byte boundaries. It has to be instant initialized when it's created, or grown, or auto-grown, because a previous usage of that portion of the file, or I should say the volume, could happen to have some bits and bytes that look like a log record. Highly, highly improbable, but a very small finite possibility. And so SQL Server would merely be recover, 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 puke, fall on the floor. Okay? So that's why it has to be instant initialized. Now, you may be thinking, well, what happens if it has wrapped around? How does it know where to stop? Because log records and portions of the log are never zeroed out after they've been already created. So imagine that the log has wrapped around. So the process that goes on in the transaction log while regular things are happening is called clearing or truncating the log. As it says in the slide, both horrible misnomers, because nothing is cleared and nothing is truncated. Okay? All that happens is there's a bit in the header of what's called a virtual log file that says, this is now reusable. Okay? And so when the log wraps around, it can start overwriting what was there before. Now, it overwrites complete log blocks. Log blocks are sized from 512 bytes up to 60K. It's supposed to be a 200 level session, but we're now at 500 level, whatever. Tangent. Size from 512 bytes to 60K. Every time a VLF is reused, there's a set of parity bits that this usage of the VLF has to adhere to. And it flips backwards and forwards between 64 and 128. Each log block is stamped with 64 or 128. Okay. So when a VLF starts to be reused, the parity bits will flip. And so all the new 512 byte blocks will get stamped with the new parity bits, either 64 or 128. Okay. What was there before won't get overwritten until it has to be actually reused. So when a crash occurs and the log has wrapped around, it carries on reading, follows the log around, carries on reading until it comes to a log block in a VLF that has the wrong parity bits. And that must be something that has not yet been overwritten. And so we know we found the end of the log. That's where crash recovery knows where to stop. Okay. What was I going to say here? Oh, yeah. So bottom point. Because the log has to be zero initialized, almost messed up there. Because it has to be zero initialized, this doesn't apply just to log files. It applies to everything. If you're going to restore a database, don't drop the files first. If you're going to completely overwrite it, don't drop the files first. Okay? Allow the restore system to make use of the space that's already there, to cut down on the time that it has to take to do zero initialization. Because if you whack all the files, it has to create them all again. The very first phase of restore is if the files aren't there, go create them. Right? If it has to go and create a terabyte-sized log file, you're going to sit there waiting for 5 or 6 hours while it does the zeroing, and then goes and overwrites it all. Okay? Complete waste of time. Don't do it. Number 12, we need to speed up a little bit. Number 12, the log should always be as small as possible. No, it's not. Depends. Busted. The log has to be the size it has to be. Okay? And that's different for everybody. Everybody in the room is going to have different size log files. Even if you all had the same database, you've all got different workloads. So anytime anybody says to you, well, your database is this size, that means your log file should be this mathematical formula, this size. They're completely wrong. Okay? There's no basis to that at all. Okay? It totally depends on what you're doing with your database. You could have a 100 terabyte database with a 10 megabyte transaction log. If you're not doing any updates, it doesn't need to be any bigger. Right? So how big should your log be? There are some things you can look at. They're all listed there. Right? So the log has to be able to hold essentially the single largest transaction, whether that is one ginormous thing that somebody does accidentally, or maybe it's an ETL process, or maybe it's the index rebuild of your largest index, and you're using the full recovery model. Right? That is a single transaction. None of that can ever be overwritten until that transaction has finished. That's how big your log is going to have to be. Quick? You got it? Good. If you are using database mirroring, and you allow there to be a send queue, okay? So a bunch of transaction log that hasn't yet been sent across to the mirror. If that log was overwritten, then your mirror would be toasted, basically. Question? Interesting question. So the gentleman asked, should the log be twice the size of your largest transaction to save space for rollback? I would say no, don't make it twice the size. So what he's talking about is, well, let me finish my train of thought first. Pop the stack. Okay. Database mirroring. So all those log records that are part of the mirroring send queue have to be persisted. They can't overwrite those. Okay? So the larger your database mirroring send queue is, which is roughly equated to the amount of data loss you're going to have if your principal dies, that's how big your log has to be. If you're using transactional replication, there's a log reader agent job that runs on the distributor that goes up to the log and it pulls everything down that's part of a publication. If you've changed that so it's not running very frequently, maybe you've got contention issues on your log, then how often does that run? If that runs every 6 hours, then you're looking at 6 hours of transaction log has to be held in your log until the log reader agent job has processed it. Log backups, same thing. If you change your log backups so they're only running every 3 or 4 hours, 3 or 4 hours of transaction log. And then the one that most people don't think of, which is how long does it take for your longest data backup to finish? While a data backup is running, full or differential, the log cannot clear. Okay? If you have a full backup that takes 12 hours to run once a week, then during those 12 hours, the log cannot clear, and it has to be as big as is necessary to hold all the log generated in that time period. This leads to one of the other misconceptions which I debunked last year, which is, do data backups ever clear the log? No. But the mechanism makes you think they do, because I said that log cannot clear when there's a data backup running, and that's true. But if you have concurrent log backups that run while your data backups are running, they're supposed to clear the log. But they can't, because that log is required by the data backup. So what happens is the backup system remembers that there's been a log backup backing up to this log sequence number, and then another one backing up to this log sequence number. When the data backup finishes, it says, oh, there's been a concurrent log backup. I'll go and do the log clearing that was deferred. So you can see why it looks like a data backup cleared the log, but it didn't. It was deferred log clearing from concurrent log backups while data backups were running. Now, getting back to this gentleman's question. Would you need to have twice the size of the log of your largest transaction? And the answer is, I would say, generally no. What we're talking about is a thing called log space reservation. What the log does is it ensures that there is no possibility of running out of log space and a transaction not being able to automatically roll back. Okay? There's been bugs in this over the years. I fixed one of the bugs myself as part of looking at the log management system for 2000. What it does is, as it's generating log records for the forward part of your transaction, actually I've been going this way, so the forward part of your transaction, right, it's also reserving free space in the transaction log to be able to write the log records if you decide to roll back that transaction, guaranteeing there is enough space to do the rollback without having to grow the transaction log. In other words, guaranteeing that if you run out of space in your log, your database is not going to go suspect because transactions couldn't roll back. And this could be up to, say, 50% of the size of your log, but it isn't usually that much. Okay, it's a kind of conservative estimate. And the reason it's not 50% is because the forward, this way, part of your transaction usually is generating in the log records before and after images, right? Depending on what the operations are, of course, before and after images. The log records that are generated when you do a rollback, they're special log records. They're called compensation log records. Kind of think of them as anti-operation log records. Right? They only log the after image, not the before image, because compensation log records, which are doing rollbacks, can never be rolled back. They can only be replayed as part of crash recovery of part of a rollback. So in general, the log records that are compensating for your transaction are smaller than the transaction log records on the forward part this way of your operation. Answer your question? Perfect. Okay. Number 13, log records can be removed from the log. True or false? Everyone's just listening to Gail, so that's not fair. No, you're fine. Busted. Log records can never be removed from the log. Right? It is not possible to remove log records from the log. Now, you might see a case that looks like it. Imagine that you are running transactions, as many of you do, and the system crashes. Right? If a transaction hasn't committed, then there is no guarantee that the log records for that transaction have to be durable. Okay? The D in the ACID properties of a database. That is only guaranteed if the transaction commits. Okay? So there could be a log block, 60K's worth of log records that are just about to be written to disk, and then everything crashes. Not from a committing transaction. Okay? And so when the system starts back up again, those log records don't exist. Because they weren't part of a committed transaction, they don't have to exist. Right? And that's fine. I can see some kind of what faces out there. That's fine because the data pages that those log records changed also didn't hit the disk either. Okay? So the fact that the log records just disappeared out of memory when the system crashed don't cause any problems. They weren't removed from the log. They never got written to the log in the first place. Okay, because there's two conceptual ways to think of the log. There's the log on disk, okay, and there's the log that's in memory. And there's always log that's in memory that might not be on disk if you've got transactions happening. This is how logging works. It's called write-ahead logging. So if a crash occurs and a transaction hasn't committed and you haven't seen the yes, we committed, then everything your transaction did, if it's a small transaction, might just disappear. And that's totally fine. Because if your transaction didn't commit, it's going to roll back anyway, okay, when the system comes up and runs crash recovery. So there's no reason that those log records that were kind of ephemeral and not yet persisted just disappeared. Okay. So that can look like things are removed from the log, but that's not. That's a kind of special case. Okay. Log records that are in the log on disk are never removed from the log. Okay. They could be overwritten once they're no longer required as part of the clearing and truncating the log. Okay. But if you do a rollback, say you've got a long-running transaction. Now, you're generating log records this way, remember, and we hit a 60K block size in the transaction log. At that point, that block has to get written to disk. It's how the log management system works. If you then do rollback transaction, as I just explained, every operation that you did on your transaction has to be undone, which means looking at the log record and undoing them in the reverse order. And the undo is generate another log record. Okay, there's no way for the system to say, well, I did these operations as part of this transaction. I'm just going to go and mess around with the data files over here, and we'll just call it good. Okay? Every change has to have a log record describing it. Okay? So log records are never removed. Corruptions can disappear. True or false? Not really. Not really. A corruption is a corruption. Okay? Whether we can detect it can change. Okay? So there is this phenomenon of what I call disappearing corruptions. And what can happen is your nightly check DB, because you're all running nightly check DBs, right? Yeah? Good, good. Your nightly check DB job finds some corruption. You come in the morning, you run check DB again, and it's gone. Does that mean the corruption disappeared? No. What it means is that the data file pages that had the corruptions on that were part of your database when CheckDB ran the first time now aren't part of your database anymore. Maybe an index got rebuilt, and so those pages got deallocated. Or there were transient problems with your I/O subsystem. Perfectly possible to get transient problems. Okay? That's the common case now. Okay? Because if CheckDB tells you there's a problem, then there is a problem now. In 2000, not so much. Okay? There were some interesting issues in 2000 with CheckDB. Who remembers the old, in 2000, if CheckDB tells you there's a corruption, either run it again or run it with tablock. Anybody remember that? Yeah. Sorry. There weren't actually bugs. In 2000, the way the logging worked, some operations, it didn't log absolutely everything that was necessary for CheckDB to figure out what was going on. Because what CheckDB does now, from 2005 onwards, is it creates a database snapshot, and it runs CheckDB against the snapshot. Because the snapshot is, by itself, a transactionally consistent point-in-time view of the database. Perfect, just what CheckDB needs. They didn't exist in 2000. So in 2000, what we had to do was, when CheckDB started, it would prevent log truncation from occurring, which could cause ginormous transaction logs. And then, at the end of reading everything from the data files, which is completely inconsistent because you've got transactions happening at the same time, it would go and analyze all of the transaction log and essentially run crash recovery inside CheckDB. Horrible, horrible code. Okay, great fun to work on, but horrible, horrible code. The problem is that some of these operations didn't log absolutely everything necessary for us to be able to figure out exactly what happened. And so we had to make an educated guess. And every so often we hit a pathological case where our educated guess was unfortunately incorrect. And so you'd be told there was a corruption when there wasn't. Okay? Which was better than being not told that there's a corruption when there is. Okay? Kind of, I guess. Right? But anyway. So nowadays, though, corruptions, if you see a corruption, 2005 onwards, there really is a corruption, or there really was a corruption. Okay? Now, right down at the bottom there, CheckDB creates its database snapshot. By default, it's going to create a hidden database snapshot using NTFS alternate streams on the data files that currently comprise your database. There have been, actually I don't know if there's any at the moment, there have been various third-party tools vendors who have put out file system filter drivers that don't cope with NTFS alternate streams. And so when CheckDB would start to read from these alternate streams, it would just return a whole bunch of garbage. And so CheckDB would think there was a problem. The most famous of these was one that Jonathan and I did one December 2009. Diskkeeper 10 had a bug in it where it didn't cope with alternate streams properly. Okay, and Jonathan found it, and we debugged it one evening. So beware of third-party file system filter drivers. If you do some kind of upgrade and suddenly everything goes to hell, okay, have a look and see whether you upgraded something that installs a third-party file system filter driver. Okay. Yes? Okay, so what Bob is asking is, if you've got mirroring and you're running 2008 and it detects a corruption, will mirroring fix the corruption? The answer is yes, it'll try to. On Standard and Enterprise Edition, there's a feature called automatic page repair. And the way this works is, so you're running something on your principal server, it hits an 824. You will see the 824 once. Okay? Once the 824 has been hit, it queues up an automatic page repair. It marks the page that was found as in restore. So subsequent hits on that page won't get more 824s. They will see error 829, which says this page is in the middle of being restored. If you're doing a single page restore, you'll also get that error if you try to hit a page that's in the middle of a single page restore. But anyway, so then the mirroring system will go over to the mirror and say, hey, give me your copy of the page, as long as it's not corrupt, obviously. Okay. And the mirror will eventually give that page back. Now, I say eventually because there is no guarantee that the mirror is completely caught up with all the log records that have been sent across to the mirror from the principal. Okay. So we think of a timeline, and this little stick is my timeline. Okay. So the principal database is at this point here in time. This represents all the transaction log that is on the mirror database. Where my fingers are here, that's the point to where the mirror database has recovered the transaction log. Mirroring is constantly running recovery on the log that's been sent across to it. So if at this point in time, the mirror database gave that page back to the principal, there's no guarantee that it's the right version of the page. The mirror database cannot give the page back until all of this transaction log has been applied to the mirror database, making the mirror database at the same log sequence number as at the time that the principal database hit the 824. Then it will give the page back. Okay? So just because automatic page repair is there doesn't mean it's going to be instantaneous. And you'll see in the error log, we're attempting automatic page repair. And then at some point later, you'll see either it worked or it didn't work. Okay? Can't remember the exact wording. And it works both ways. If the mirror is redoing all its transaction log and it hits a corrupt page on the mirror, it will go and say to the principal, hey, give me your page. And the principal will immediately give the page back. Okay? Because the principal's page, it doesn't matter if it's ahead in time, because we're going to catch up with it eventually anyway, because we've got log to do that. Okay? Now, a subsequent question, which Bob didn't ask, but I know he's thinking it, is if there's corruption that occurs on the principal, will it also occur on the mirror? And the answer is, well, actually, I hope you're not thinking that, because you know the answer to that. No. The answer is no, because mirroring doesn't ship full physical page images. It ships log records. Mirroring under the covers, when we were developing it, was called real-time log shipping, because that's really what it's doing. As log records are generated, they're sent across to the mirror. Right? So if an I/O subsystem corrupts a page on the principal, that same page is not going to get corrupted on the mirror, because they're two separate I/O subsystems. Hopefully, you're not running on the same I/O subsystem. Okay? Believe me, I've seen that. Okay? Okay. That's not high availability. What was I going to say? I lost my train of thought there. Oh, yeah, okay. So, database mirroring, that's not going to happen. Log shipping, that's not going to happen. Replication, that's not going to happen. SAN replication? Maybe. Depends where the corruption occurs. If the corruption occurs somewhere in the I/O subsystem before the point at which the I/O goes like that to the remote SAN and the local SAN, then yes, they're going to go and corrupt both. Okay. Generally, that doesn't happen, though. Okay. All right. Oh, you mean the new availability groups? Same caveats to everything I've just said. Yeah. All right, number 15. A clean CheckDB guarantees no corruptions. It's been up there for 10 minutes now. You should have thought of the answer. Busted. Right. Just because you ran CheckDB does not mean that there are no corruptions right now. Let me tell you a story. Imagine that the Seattle Police Department has a policeman called Officer Paul. Very good name. I'm sure they do. And Officer Paul's job, it's a very boring job. His job is to sit in the traffic control room in Seattle and to look at a bank of monitors. And he's watching all the traffic cameras from junctions, traffic junctions around the city. And his job is, whenever he sees an accident occur, he has to phone the police chief and say, hey, there's been an accident. I can't remember who the police chief is right now. We'll call him Bob. Bob, there's been an accident. Okay. So he comes in the morning, he sits down, starts looking at the traffic cameras, and by the end of the day, he's kind of drool coming down, and so it's so boring. He presses the button to look at traffic junction number 1. There's no accident. He waits there for 5 seconds, presses the button to look at the next junction. So he's looking at junction number 2. As soon as he's looking at junction number 2, there's an accident on junction number 1. He's not going to know that until he cycles through all of the junctions. There's lots of junctions in Seattle, and then gets back round again to junction number 1. And this is an analogy to what CheckDB is doing. What CheckDB is doing is it's reading all the pages in your data files individually at different points in time, essentially, because it can't read them all at the same time. Right? So when CheckDB completes, what it's telling you is, at the time we read all these pages, there were no corruptions. Who knows what there is now? That's why you have to keep running it. Okay? Because it's not giving you a guarantee. It's just saying, it's giving you peace of mind. It's saying at the time you ran your CheckDB, there were no corruptions. You have to keep running it regularly. Okay? Oh, and backup with checksum, something I debunked last year, is not a substitute for CheckDB, because a page could be corrupted in memory by a bug or a memory scribbler, and then written out to disk with a valid checksum. And so backup with checksum will test the checksum and it'll be valid, but the page is actually corrupt. Okay? So you have to keep running CheckDB. CheckDB is just fabulous. You guys know that. Oh, I remembered something I was going to say about the previous slide. Corruption won't propagate at the physical level from a principal to a mirror, but it could at the logical level. Imagine that a page is corrupt on the principal. You don't have page checksums enabled. The page is used to read some data values, which are then used to persist something. If the data values were corrupt in some way, then the value we just created and persisted is also corrupt. That will get propagated over to the mirror. Okay? Now that's not physical corruption. That's logical corruption. That's very insidious, and it's very hard to detect. But that could happen. I need to keep going, keep going. Number 16, as long as the backup completes, the restore will succeed. Good, good, good. Enough said there. Okay, we can skip through that one. The I/O subsystem is an equal opportunity corruptor. It'll corrupt anything quite happily, okay? Including your backups and your Temp DB and everything else you store on top of it. Okay? So you can't trust your I/O subsystem, which is why you keep running CheckDB, which is why you have multiple copies of your backups. You don't store your backups on the same physical drives as your database. Oh, the stories I could tell. Okay. Question? That's 2 slides back. Come on, dude. There we go. So the question is, if you take your backup, you take it over and restore it somewhere else, you run a CheckDB on that restored copy of your database, does that give you a guarantee? No. That tells you at the time you took your backup, the database wasn't corrupt. Same thing. It doesn't tell, well, it doesn't tell you that at the time you did the CheckDB that your database wasn't corrupt, because you're not CheckDBing your prod system. You're CheckDBing a different database on a different system. There's no guarantees ever. No guarantees. Sorry. Which is why you have to keep running check DB. Okay. All right, we've done this one. And obsolescence. Yeah. All right, number 17. 32-bit everything is compatible with 64-bit systems. True or false? False. You guys were all thinking it was true. Well, actually it is. It's getting late now. You guys have been going to the 8 o'clock this morning just making sure you're all still awake. Yeah. There is absolutely no physical difference between 32-bit and 64-bit data files, log files, backups, anything. Okay. Bulk log recovery model reduces the size of your log backups. No, not maybe. Busted. Maybe by a few K or a couple of megabytes. Okay? But it could be bigger by a few K or a couple of megabytes as well. Bulk log recovery model allows minimally logged operations to not have so much transactional log generated. The backup after a minimally logged operation, the log backup I should say, has to back up all the transaction log, and because there's been a minimally logged operation, the minimal logging just logs the allocations, not the actual inserts. So if that was all it backed up, if you took that log backup and restored it, you'd restore a bunch of empty pages. Okay? So the log backup after a minimally logged operation has to also go to the data files and back up all the extents that were marked as changed by the minimally logged operation. Okay? Which means that your log backup is going to be basically the same size. Okay? Very common misconception. Using the bulk log recovery model does not affect disaster recovery. Okay. False. Yes. Because a log backup after a minimally logged operation has to go and read the data files as well. If you crash after, or SQL Server crashes after a minimally logged operation, but before the next log backup after that, and your data files are damaged, you can't do a tail of the log backup, because that tail of log backup, in other words, back up everything that hasn't yet been backed up, get me right up to the point of the crash, can't happen, because it would have to go and read the data files, and data files aren't there. So you can't do your tail of the log backup. So using the bulk log recovery model limits your ability to recover right up to the point of the crash in all cases. If you are a 24/7 system that has user transactions happening 24/7, thou shalt not use bulk logged. Okay? Unless you have some other real-time mirroring solution, because you run that risk. Number 20. Best thing to put on that new SSD is Temp DB or the transaction log. Yeah, it depends. Okay. The reason I've got this in there is because I've seen a lot of information out there saying, you know, the log and Temp DB are the #1 thing to put on your SSDs. Well, you might not have anything happening in your transaction log. Or you might have a Temp DB, which is big because occasionally it's needed, but most of the time it's not. And as Bob explained yesterday, when Temp DB checkpoints occur, data file pages don't get flushed out to disk. Okay? So you might have something sitting on Temp DB that's not actually, sorry, on an SSD that's not actually using it. The best way to get a good ROI for your expensive SSD is figure out where your I/O bottleneck is and put whatever that is on your SSD. Okay? Then you're actually going to see a gain. Okay? Or you start from scratch and you architect a system that uses SSDs because you know you need a certain number of IOPS that you can't get from regular spinning drives. But don't just knee-jerk and follow people's advice and immediately go put Temp DB or a log on your SSD. It might not be the best thing for you. Okay. 21. SSDs mean you don't have to defrag indexes. Thank you. Okay. Again, I've seen people saying that now that SSDs are so fast, you don't have to worry about fragmentation. It's completely false. Okay. So yes, the access time might be so blisteringly fast that it doesn't matter that we're doing less efficient read-ahead. But think about what's causing the fragmentation. Page splits. So page splits are occurring, and they're doing two things. They are generating an awful lot of transaction log, and they are causing pages to be less than 100% full. Now, do you want to have a whole bunch of fragmented indexes, okay, with maybe total 40% unused space on your extremely expensive SSDs? In other words, do you want to store empty space on your SSDs? No? Do you think your finance people are going to like that? No. Okay. you'd still have to take care of fragmentation. And then the page splits themselves generating transaction log. Okay? Very, very expensive operations. Lots of transaction log in every recovery model. Just because your access time to your SSDs is fast doesn't mean you want to sacrifice overall performance by allowing page splits to carry on occurring. Okay? No, you still have to take care of fragmentation. You can fix heap fragmentation by creating and dropping a clustered index. Yes? No? Yes, it's true. Of course you can. Doesn't mean you should, though. Okay? Because when you take your heap and you create a clustered index, all your non-clustered indexes have links back to the base table, whether your base table is a clustered index or a heap. The non-clustered indexes have links back to those base table records. If the table is a heap, then that link is the physical location of those records. If your base table is a clustered index, then that link is the cluster keys. Both of these are unique. If you take a heap and you create a clustered index, then those heap linkages aren't there anymore. And so all the non-clustered indexes have to be rebuilt to pick up the clustered index keys. So the links work again. And then if you drop the clustered index to go back to a heap, then all the cluster keys are no longer valid, so all the non-clustered indexes have to get rebuilt to pick up the new heap physical locations. Okay? Not good. Okay? So to get rid of heap fragmentation, if it's causing you an issue, the best thing to do is just create a clustered index. Stop. Okay? Now, what clustered index should you create? That's a question for my wife. Okay? Unique, narrow, static, and ever-increasing. That's your clustered index key. 23, disk queue length should always be very low. Excellent. Busted. Every single running thread in SQL Server can issue IOs. Right. So there is no reason that your disk queue length should be always 1 or always 2. Right. No, it can spike quite happily. You run CheckDB on your system. Go monitor the disk queue length. Okay. You'll see hundreds, potentially thousands, because it tries to saturate the IO subsystem. Does that mean there's a problem? No, it's just CheckDB. Okay. I don't need to say anything else, it's just CheckDB, right? Yeah. Now, saying that, generalization, oops, I'm about to trip over my power cord. Generalization, you want it to be pretty low. If it's sustained high, that's probably showing you've got some kind of IO subsystem overload issue. But it doesn't mean it's an IO subsystem issue, though. It could be you're driving more IOs than your IO subsystem is spec'd for because something's gone wrong inside SQL Server. Okay? Plan changes or all kinds of different things. Okay? But generally, you want it to be low. Okay? But it doesn't have to always be low. 24. 300 is a good PLE threshold. Thank you, whoever shouted crap. Yes, now, 5 or 6 years ago, when we all didn't have very much memory, that was a reasonable threshold to start worrying. Okay. Now, PLE is not a rolling average. It's an instantaneous measure of how quickly things are being thrown out of the buffer pool to create space, because there are things that require space. Okay. So 300 is saying that basically every 5 minutes, your entire buffer pool is being replaced. If you have, say, a 100 gig buffer pool, are you going to start worrying only when that gets down to 300 and stays there? No. Okay. Now, it's not that I'm saying that 300 is, or any threshold is wrong. It's that 300 is way too low a threshold now to start worrying. Jonathan just did a blog post, and he came up with this formula down there at the bottom. Okay. That is a better threshold to start worrying. If your PLE drops down there and stays there, then start worrying. If your PLE kind of spikes down and comes back up again, that's just what happens. Okay? It's if you're monitoring and you're like this, and then it takes a nosedive and stays there, you've got a problem. Okay? But don't use 300. You want to worry about it way before it gets to 300, okay, depending on your system. Okay? Thank you, Jonathan. CX packet weights mean disable parallelism. I love you guys. Where's Buck with my extra coffee? Busted. Okay. 6 packet weights mean you've got parallelism going on. Okay. So you've got parallelism going on. It depends whether that's something that you need to actually worry about or not. Okay? If you have a pure OLTP system with what should be very, very small transactions, and your top weight is CX packet weights, yes, I would start worrying about that. Okay? That means that your very small transactions are not doing what you thought they should be doing. Those index seeks have maybe turned into long, large table scans. Right? But in general, you only want to start worrying about this if, as I said, OLTP system. Now, if you find that there's a problem, does that mean you go and set max DOP to 1? No. Okay? Probably one of the worst things you can do in general. Okay? Parallelism is one of the coolest features that helps performance in SQL Server. Okay? Making use of those extra cores that you've got. Don't turn it off unless you absolutely have to. Okay? If you find that CX packet weights are an issue, okay, don't turn max DOP to 1. Play around with some other stuff first. Maybe consider that single query set max DOP to 1. Okay? I've had to do that on one of our customers, not for this actually, but for a thing called intra-query parallelism deadlocks, where you've got parallelism going on, and the threads that are part of the parallel operator deadlock with each other. And every single one of those, 100% is a bug in the query optimizer. But they can't be fixed. Okay? Connor would love to know about them, but they can't be fixed for the most of the time. Your only option is turn off parallelism for that query. Okay? I've only had to do that once. Okay? But consider just setting max DOP to 1 or lower for those problem queries. Okay? Consider raising cost threshold for parallelism so that those queries don't run in parallel. And it's only those queries that really have to that run in parallel. I'll see your hand, but I'll answer it in a second. Consider using resource governor. Okay? You can set a particular workload group to have a max DOP. Okay? And that can't be overridden. Server-wide max DOP, anybody with any privilege can do a max DOP hint and override it. But not if they're in part of a workload group that has a max DOP limit. The resource governor max DOP limit cannot be overridden. Okay? It's not possible. Okay? Question at the back. Oh, I covered it. Perfect. Okay. Now, we could devolve for hours and hours into all the different weight types and what they don't mean. Okay? For instance, async network I/O. Does that mean it's a network issue? No. Okay? I could run a large query on my laptop here, and we would see async network I/O. Why? Because SSMS is poorly written. Okay? Applications that are poorly written and do not cache and process the records and make SQL Server wait for an acknowledgement will show up as async network I/O. Right? It's not network, it's application. A large proportion of the time that I see that. Okay. OLADB doesn't necessarily mean that it's an OLADB issue. If you run CheckDB, you'll see OLADB waits, because it uses OLADB to talk between the query processor and the storage engine portions of CheckDB. Doesn't mean you've got an OLADB issue, it just means you ran CheckDB. See, I managed to put CheckDB into every third or fourth slide. It's pretty clever, actually. 26, log backups will be the same size as the log itself. I've already explained this one. You guys should get this right. Yes. Okay. For exactly the reason that this gentleman raised, okay, which is why I hesitated to answer it. Yes, because of log space reservation. The empty space that's in the log doesn't get backed up. It's pointless. So if you might have a 100 gig log and you've got lots and lots of stuff going on, you do a log backup, maybe your first ever log backup, and it says 99% of the log is used. You do a log backup, it's 50 gig maybe, or 60 gig. It's because of log space reservation. Okay. Differential backups are incremental. False. The only incremental backups that SQL Server has are transaction log backups. A transaction log backup will back up all the log generated since the last log backup. A differential backup will back up all of the data extents that have been changed since the last full backup. Differential backups are cumulative. The confusion comes because other RDBMSs do have incremental differential backups. We don't. Okay? We're still better, but we don't have those. Okay? Replication is a valid HA technology. True. Thank you. Yes. Now, replication can be a pain in the ass. It can get its knickers in a twist. It can be really horrible to set up, to get rid of, to change. But it does work. Okay? And it's a lot more stable than it used to be, absolutely. Yeah, it sounds like false. Now, but what I'm saying is, it has a whole bunch of issues. It can be very complicated, but so can all the other HA products, or technologies, I should say. This one a little bit more than others, though. But if your SLAs, service level agreements, downtime and data loss, allow you to use replication, and that's the thing that you want to use, then knock yourself out. It's cool. How many people use replication here? You can't all be wrong, right? It's a cool technology. Okay? As I said, it can be a bit twitchy, but it's a cool technology. And as it says down there, peer-to-peer replication is the only thing we have right now that allows you to write to essentially the mirror of your database. Okay? So don't discount replication. I wrote a long article last year because I was getting so annoyed with people saying, don't ever think of replication if you're thinking about HADR. Why not? Depends what you want to do. Okay? No, it's just that I'm British and I write things strangely. Yeah, make sense? There you go. Just think British. Okay? It explains so much, it really does. All right, 29. You should always plan a backup strategy. Yes, absolutely. Let me tell you a story. Some of you may have heard this story before. Okay. So back in 2004, when I was a dev lead on the storage engine team, I went on a program called Frontline. Eric Rudder, who used to be at Microsoft, maybe he's still at Microsoft, Eric Rudder, had this program to get senior people out into the field to learn about the issues that customers were having. Because Microsoft had this the view of Microsoft was that people didn't really understand what customers were doing. So this was a kind of go out and see customers and learn some stuff. So I went out, and the first week I was with the product support people in Charlotte, North Carolina. And I was helping on a thing called the server down queue, where people call in and say, help, my server is down. And this bank called in from the Midwest and said, hey, we've got corruption. Well, actually, they were a bit more upset about it than this. Hey, we've got corruption, and we need your help. So we said, okay, what backups do you have? And they said, we don't really want to go there yet. So we kind of looked at each other and thought, okay, because I was sitting in somebody's cube helping them out. And then we said, okay, well, if you don't want to go through your backups, we'll take a copy of your database, we'll copy it over, restore it, run, repair. We did that, and it deleted a whole bunch of data, because that's what CheckDB does. Drop what's broken and fix up all the links. Still fabulous, though. And, and they said, okay, that's not palatable. We can't have any data loss. Well, yeah, you're a bank, okay. So what backups do you have? And they said, okay, this was April 2004. They said, we have a full backup from January 2004. And we've been taking log backups every half an hour since then. So we very quickly hit the mute button on the phone. And we do what you're doing as well. And we laugh. We wipe the tears away. And we compose ourselves. We're professional senior people here. And we hit the mute button and we say, oh, that's not very good. And they said, no, it's a bit worse. They're all on tape. Mute button again. You know. Now, so we're thinking, there's no way this is going to work. So compose ourselves, hit the mute button. Okay, so here's what we're going to do. And we created a script, and lo and behold, miracle of miracles, every single one of those backups restored perfectly. 5,000. Over 5,000. Okay? That's the key. It took 3 days. Okay? Now, while they were doing this, the entire bank was offline, down, nothing. Oh, I don't remember that now. Don't remember. Now, the entire bank was down. Okay? So no ATMs, no tellers, no payments, no mortgages, nothing. Now, for those of you that live around here, there's a credit union called First Tech. If you used to work at Microsoft, you probably bank with First Tech. If First Tech were down for 4 hours, I'd say, well, yeah, stuff happens. Whatever. If they were down for 3 or 4 days, I'd be banking somewhere else. And that's exactly what happened. They went out of business because of that. And here's what they did wrong. They planned a backup strategy. They did not plan a restore strategy. Okay? Do it backwards. Well, don't restore your backups backwards, that won't work. But Plan your strategy backwards. Figure out what you want to be able to restore and how quickly you want to be able to do it. And that's going to dictate what backups you have to use. Okay? They did it the other way around, and they got burned. Okay? Don't let that be you. Now, it is 1:15. This is the time that regular sessions finish. This is not a regular session. This is a 90-minute session. So if you want a beer or go to the bathroom, don't. Just wait. Okay? Obviously, don't make a mess, but yeah, just hold on. Okay? We have another 15 minutes of cool stuff still to go. Jonathan's question is, am I going to make it worth your while to stay? You're fired. 2 days ago, I did it by proxy. Today, for real. Okay. Should he stay or should he go? Should he stay? Stay. Not many people put their hands up, buddy. No, he can stay. He'll cry otherwise. All right, we've got 5 more. What does this say? Wow, these screens are horrible. Log records can move in the log. True or false? We're getting a bit more complex now. Can they move in the log? Absolutely false. Okay? Every log record has a unique log sequence number. The log sequence number has 3 parts. The virtual log file, the log block within the virtual log file, 512 bytes to 60K, and then the log record number within the log block. Think of a log block as a big page, okay, with a bunch of records on. If it moved, it would have a different LSN, which would completely break everything. Okay? So they never move. Okay? And I've heard of people, even recently, saying things like, if you do a shrink file of the log and it forces it to wrap around, it moves what was there down to here. Absolutely not, never. Okay? Under the covers, it fills it up with nothing, and then it forces it to wrap around. Log records never move. Database snapshots are very efficient. It depends. Yes and no. They're very efficient in terms of on-disk storage. They suck in terms of memory. Okay? Because every page that you read through the context of a snapshot has to have its own separate buffer in the buffer pool and has to be mapped in to the buffer list that the buffer pool has for the snapshot database. A snapshot database is a first-class object inside SQL Server, just like any other regular database, which means that there's no way, it just wasn't implemented, very hard to do actually, there's no way for the real database and the snapshot database to share essentially the same buffer, even if that page is unchanged in the source database since the snapshot was created. So you'll actually see a page taking up 16K in memory. 1 copy for the source database and 1 copy for the snapshot database. Question at the back. So the question is there any limitation on the size of the snapshot? So you're going to be limited by your volume size, which is limited by your NTFS allocation unit. You're not going to be able to have the snapshot be bigger than the size of the source database at the time the snapshot was created. So that's the first thing I would say. If you've got an extremely large database and you don't have enough space for twice the size of that database, you might run out of space, depending on what you do with the snapshot. So that's your limitations, wherever you went. There you are. Okay? Cool. Yes? Interesting question. So I said earlier on that CheckDB creates database snapshots. Absolutely it does. So the size of a database snapshot depends on how much changes in the source database after the snapshot's created. Okay? So if you have a completely quiescent database, you create a database snapshot, the database snapshot's going to be 64K, and it won't ever grow until you change something in the source database. Just before the buffer pool is about to mark a page dirty and allow the access methods to change it, the copy of the page that existed at the time the snapshot was created will get pushed into the snapshot. Okay. So the question of how much memory that snapshot that CheckDB is using will take up depends on how many changes you make to the database that you're running CheckDB on. That make sense? Yeah. So if you don't change it at all, the snapshot's going to be really small. And remember, the way that a snapshot works is when you go to read a page through the context of the database snapshot, the buffer pool looks to see whether that page exists in the snapshot, because the buffer pool manages all this stuff. If the page isn't there, then it reads it from the source database. Okay. So there's also a component of how much activity there is in the source database while CheckDB is running, even if you don't make changes. Because if you have a workload, say you've got a 100 meg database, and you can read the entire 100 meg of your database in the same time it takes CheckDB to read the 100 meg. That's going to take up roughly, give or take, hand wavy, 200 meg of buffer pool space because of the double accounting. Okay, so there's two components to it. How much do you change, and whether you've got concurrent activity or not. That's an interesting study that I've never done. Can you make a note? I'll play with that. You want to get, yeah, that's right, it doesn't work for me anymore. Touche. I love him. All right, using temp tables for intermediate query results is always a good idea. Yes, that's the key. Always? No. Okay. It totally depends. The reason this is in there is a few customers of ours over the last, I don't know, year or so, we found massive temp DB space usage problems because the developers love dumping the intermediate results of complex queries into temp DB, in temp tables, okay? Rather than just using something like, I don't know, CTE or just a big query and just letting the optimizer do its thing. If you create a temp table, you are forcing the optimizer to interrupt the flow of data through your query. You are forcing the storage engine to materialize the data set in temp DB, even though it might not actually need to. If you didn't have the temp table, okay, potentially, it could come up with a different query plan where there wasn't the need to materialize a very large data set, okay, because of the nice pipeline of data flow through your query. So just because temp tables are there doesn't mean that they should be used everywhere. Okay? Investigate whether you can remove the temp tables and reduce increase the speed of your queries, and B, reduce your temp DB space usage. Okay? Another thing to consider, hold on, John. Another thing to consider is when you're creating your temp tables, don't do select star from these permanent tables into the temp table and then use one column from the temp table. Okay? When you're creating indexes on the temp table, right, create them after you've populated the temp table, not before. Make sure that you don't create one index per column in the temp table. Okay? That's probably not going to be useful either. John, hold on a sec, Erland. Table variables don't use temp DB. They do? What are you saying? Uh-huh. Did I say that? Oh, good. Okay. I thought oh, yeah. John wanted me to make the point, this is what was confusing me, that a table variable is not a good replacement for a temp table because they use temp DB as well. Okay? He confused me because I thought I'd said that, and I didn't. Erland. But then you'd also have good statistics, so the optimizer would know what to do with your data. That's the main point. If you only have 6 rows in your temp table, nobody cares anyway. So I'm not putting you down, Erland. Yeah, you're correct. Yeah, you got to be careful of caching. But yes. If you had to use a temp table, no. If you have to, use a temp table, because if you do it in a user database, the logging is more, because it's going to log extra stuff, whereas it won't in temp DB. Checkpoints will flush everything out to the user database, whereas for temp DB, it generally stays in memory. Doesn't matter. It's even a scratch database in simple mode is still less efficient than temp DB. hold the Temp DB questions till the end. Let me get through the rest of the slides, and then we'll go through questions, okay? I want to make sure that everyone that wants to leave at 5:30 can. Or just lock the doors, whatever. Yeah. Okay. All right, only a couple more. Fully logged means you'll always see one log record for every part of the operation. Yes, it's false. That is not what fully logged means. Fully logged means there is enough information in the transaction log to fully reconstitute the operation after a crash. That does not mean there has to be one log record per row. If you have an index with, say, I don't know, let's say 1,000-byte records, okay, and you have 100,000 rows, and you do an index rebuild, in the full recovery model, you will not see 100,000 rows. You might see 7,000 odd rows. Because instead of logging an insert row log record for every row as part of the index rebuild, it will build full pages and log the full page image. That's still fully logged. All the information necessary to reconstitute that index is in the log. It's a much more efficient way of logging than one log record per row, because you don't have all the extra overhead of log records for every row. You have the extra overhead of log records once per page. Okay? Much more efficient. Okay? No lock and read uncommitted means no locks. Good. Yes, busted. There are times when even a no lock or read uncommitted scan, which are the same, have to take locks. Anytime it's doing a scan, it has to take what's called a schema stability lock to prevent the shape of the table changing underneath the scan. If it's scanning on a heap, it also has to take a bulk operation lock to prevent bulk operations on the heap so that it doesn't accidentally see an unformatted page. Okay? Because reading a heap, it's unordered, so it can just zip through and pick up all the pages. The way that bulk operations work is instead of allocating page by page by page by page by page, an extent is allocated, and then all 8 pages are marked as allocated in one log record. So there's one log record for 8 pages, marking them as allocated in the PFS page, rather than 8 individual log records. Again, it's more efficient. So there's the potential for a no-lock scan, if it didn't do this, to read those unallocated pages, and then SQL Server does its puke on the floor trick. Okay, not good, never good. Okay. Something else I was going to say there as well. Oh yeah, so no lock just means don't take any relational locks. It doesn't say anything about latches. Okay? So you can have pages in memory that you don't take locks on. That means nothing to the storage engine. A thread cannot touch a page or any other data structure inside SQL Server, and a page is just an in-memory data structure, unless it acquires a latch on the page. Latches are kind of lighter weight locks. Okay? I think they're documented in books online. It's not secret stuff. I've got a bunch of blog posts on them, and Jonathan's Gail's probably done some blog posts on latches as well. Okay? And you can think of a latch as just a lightweight lock, protecting a data structure. So a thread that wants to read a page has to acquire a share latch on the page, including no-lock scans. Okay? A thread that wants to do an update on a page has to acquire an exclusive latch, just like an exclusive lock has to be acquired on a record, for instance. So you can still have contention issues even with no-lock scans. Okay? And I'm not going to get into whether you should use no-lock or not. That's a whole big can of worms. Okay? Last one. It depends. Yes, it really, really, really does. Okay? That's why my shirt says it depends. Okay? Every single question, nearly every single question about SQL Server, unless it has a really obvious answer, the answer is it depends. Or I should say, the answer starts with it depends. Never accept it depends as the answer. Always push for why it depends, what it depends on, who it depends on. Okay? There is one question, though, that the answer is very simple. Should we have auto shrink on? Everybody, 1, 2, 3 together? No. Thank you. Okay. I'm not finished yet. All right, just in case I went early, which we didn't, I had a whole bunch of other stuff that there are myths around. All this stuff is untrue as well. Okay? To finish off, though, if something sounds fishy, it probably is. Don't take anybody's word for it. Don't take my word for it. Okay? I make mistakes on my blog. Go check something out. Go try it. Corroborate it with what's in Books Online. Books Online is now pretty fabulous at what it documents. Okay? It's been getting an awful lot better. Okay? Go do some investigation and see whether like 4 or 5 people that you trust say the same thing. Okay? There's a bunch of information that I blogged last year, my misconceptions section on my blog. There's also a PDF that you can download a whole bunch of myths. There's also a new thing we've been doing this year. We have a newsletter with no marketing, advertising junk. It's just lots of demo videos and more of this kind of stuff in that we put out every 2 weeks. Go sign up for that. Apart from that, thank you very much. Hope you enjoy the rest of your pass. Thanks. I'll stay for questions. Come up here.